Yeah. Hello everyone. So now I am going to explain how to implement a virtual lab. So for that, now you can use any one of the web browser for connection of the virtual lab. So for that, you can type VLab in any one of the browser. Okay. So like that, you will going to observe. So after click on this virtual lab URL, so you can get like this. See here, it is virtual lab is basically one of the initiative of Ministry of Education under NIM city mission. There are major institutions are participating in this development of the virtual lab. You can observe here, like reputed institution in India, IITs. All the reputed IITs are participating. In addition to that, IISc Bangalore also participating for implementation of this virtual lab. Uh, Under electronics and communication engineering, you can observe the basic electronics ec- experiments. Okay. So as per our lab, there is a uh, electrical and electronics engineering workshop labs. We have mainly eight experiments. No? All that experiments also you can observe under our V lab. Okay. So you can select the basic electronics lab and see here it provides some of the introduction information and objective of this basic electronics lab and followed by list of experiments. So here you can observe there are total 17 experiments. Okay. Minimum four experiments we are going to conduct. Okay. So for that, I am suggesting the first experiment followed by fifth one and sixth or seventh. Okay. So these are the experiments is sufficient for getting the knowledge on how to implement or how to conduct an experiments by using this platform, virtual laboratory. Okay. So for that, you can click on this first experiment, that is a familiarization with resistors. So here, if I give any resistance colors in the sense, you need to calculate the value of the resistance. But actually, the aim of this experiment is here the function and the units of resistors, and also how you can measure the value of the resistor, and followed by the tolerance of the resistors, and also the type of resistors that we are having. Okay, the types of resistors are nothing but there are four band resistors as well as the five band resistors we are having currently. Okay. So which provides the theoretical information related to the resistors, no? So fixed resistors as well as the variable type of resistors are also available, and that can be so that can be manufactured by using different type of films on different type of materials. Okay. See, you can observe here is the so fixed resistors and there is the variable resistors. Now we are having. So if you observe the fixed resistors here, there are four band resistors and there is a five band resistors. Okay. So that is a four band resistors. You can observe there are four colors. So first one is reached, second one is reached, third one is multiplied, and the fourth one is the tolerance. Fourth color. Okay. In the five band, first three are digits, and the next one is a multiplier and followed by tolerance. So in our laboratory, actually, we are using a four band type of resistors only. In industries or industry level, they can use the five band resistors. Okay. You can also observe the physical appearance of the resistors and their color coding. Okay. So it is basically a two-terminal device, right? Okay. So these are the colors, no? Basic colors for the registers is black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, and no color. Okay. We are assigning for each and every color, we are assigning some numerical numbers 0 to 9. And the multiplier means that is 10 to the power of 0, 10 to the power of 1, and so on. No? And the tolerance is There are three: gold, silver, and no colors. So tolerance value for the gold is 5% and silver for 10% and none, that means no color means 20%, plus or minus. Okay. See, here is the carbon film type of resistors. It will appearance like this, no? And the metal film type resistors are appearing like this. And these two type of resistors you can observe in our physical lab. Yeah. So these are the color band for the different resistors and their digit number and multiplier numbers and tolerant values are also available. Okay. So now we can move on to the simulation aspects. So there are some six exercises we are having. No? Okay. See here the simulation 1 and to the simulation 6. A very simple thing it is. So we discussed earlier in the laboratory in the beginning of the lab na, how to calculate the resistance values based on the color coding and assign digit numbers and multiplier things we are going to consider. And finally, we are also adding the tolerance to calculate the final value of the given resistor. See here, these are four band resistors. Okay. So first band color is yellow. So yellow means that is four digit we are assigned for the yellow. Okay. Here also you can observe the digit numbers and the corresponding colors and their multiplier and tolerance values. The second one is violet. For violet, we can assign the 7 digit. And for the next color, it is an orange. For orange, it is 3. That means multiply 10 to the power of 10 to the power of 3. That means 1K. So here we can choose the units. Either we can choose either ohms or kiloohms or megohms or gigaohms. So here we know that it is 47,000. That means 47 kiloohms. You can choose kiloohms in the sense it is 47, ohms in the sense 47,000. So here the tolerance is gold color, no? That is for 5. So now you can check out the whether it is in correct values or not, right? So that's it. So it is the correct resistance values were assigned. So the tolerance value is also correct. Okay. And all other remaining simulations experiments are available. You can go through it in a similar manner. And finally, you need to take the printout of this one, screenshot of this one. Otherwise, you can take the printout. You can go to the right side top corner and click on the print. And here you can take the can save this file as a PDF file. Then later you can send it to your mail ID. Then you can take the printout of it. Then add it to the laboratory. Okay, na? That's it. So that is about the first experiment. And next, we can move on to the second one. So that is a PN junction diode. Na? VI of PN junction diode. So actually, verification of PN junction diode already were conducted in the physical laboratory. Na? Here we have an option that is a germanium type of diode we can choose. Okay. Here we are having different options. No? One is already circuit is all drawn. Another option is we need to make the connections, then we need to do the experiments. So this silicon diode vehicles are completed in a physical lab. So better we can move on to this forward bias germanium diode. Okay. We know that the cut-in voltage for the silicon diode is 0.7 volts and for the germanium diode is 0.3. Okay. Now we can verify that one. You can move on to this instruction on the mouse. So here are the instructions, eight instructions points are given. So first thing is, the first point is we need to set the DC voltage of 0.2 volts initially and use the reduced resistor of 1 kilo ohms and a germanium diode we need to choose. Then voltmeter is placed parallel to the germanium diode and the ammeter is series with the resistors. So always remember this point. We can obtain the voltage. Okay, that should be placed parallel to the diode or the device, any device. Okay. And the current, if you want to measure the change, so that should be connected through the resistor. That means series connection for the meter and the parallel connection to the voltmeter for calculation of voltage and current. Okay. Then the remains points. Positive side of the battery That is the anode, and the negative side of the battery is the cathode of the diode. We can make the current. So already the connection is established. Just we need to apply we need to set the DC voltage of 0.2 volts and the resistance is 1 kilo ohms. Then uh, we will vary the voltage up to the 30 volts and note down the voltmeter and ammeter readings for a particular DC voltage. So then take the readings and note the voltmeter readings across the germanium diode and ammeter readings, and then plot the VI graph and observe the change. So that is the therefore from the graph you can see that last point you can observe here. Diode starts conducting when a forward bias voltage exceeds around 0.3 volts. Okay, so that is the cut-in voltage for the germanium diodes. That you can also observe in the graph. Theoretically, we know that the cut-in voltage for the silicon diode is 0.7 and for germanium diode is 0.3 volts. That you can observe in the graph. Okay, right. Shall we move on to the simulation of this experiment? So initially, we need to set the DC voltage is 0.2. See now it is movable now by using the control button option in your laptop or the keyboard. Okay, you can change the DC voltage. So initially, you need to set the DC should be 0.2 volts. Then resistance value is 1 kilo ohms. So resistance value it is already in kilo ohms now. That should be in the minimum value in the sense it is 0. Then now it is a 1 kilo ohms of resistance. Okay. Then click on add to the table. You can observe for the 0.2 volts, the voltmeter reading and ammeter readings for the forward bias it is 0 only. Why? Because the current flowing start after the cut-in voltage, after reaching the cut-in voltage. So cut-in voltage is 0.3 for the germanium diodes. That we know that. So next I am going to change to the some 1 volt of the DC or even 0.5 is also enough. Then now you can observe here the voltmeter readings also changes and ammeter readings also changes. Click on add to the table. Then next up to 30 volts we can vary. Okay. But at a regular interval of voltage you can vary. 3, next 5, 7, something. Okay. Click on add to the tables. Then you can observe the voltage and currents are changes according to the DC voltage were applied. Okay. Then later after different values of the DC, we obtained all the voltage and conversion and click on plot. See here. So after reaching the cut-in voltage, then the current flowing starts drastically. So this is the VA case of germanium diode. Okay. So in a similar way, you can implement the other experiments. That is, what are the other experiments? Either half wave rectifiers or full wave rectifiers. So you can go through this list of experiments and select the half wave rectification and click on this one, half wave rectification. This is the aim of the experiment is we are going to know about the rectification and half wave rectifier and half wave rectifier with positive half of the cycle and as half wave rectifier with negative half of the cycles. So these are the things you are going to observe. Here we are having the theoretical information, so you need to take the printout of this one and also you need to attend for this one. So what is the ripple factor for the half wave rectifiers? Okay. For example, it is a 1.1 message, then you can click on submit. Okay. You need to attend for the pre-test one, and as well, I need to know the procedure. So here we need to set the resistance value, that is the load resistance, and click on the on button of the start experiment. Then you need to click on the sine wave button and also click on the oscilloscope. Sine wave is nothing but basically in a physical laboratory in the rectifiers where is the transformer. Transformer output we are directly connected to the diode. So here in place of transformer, we're using the sine wave generator. And by varying the amplitude and frequency, we need to check out the all other parameters. You can also observe the both the input and output in the CRO, the waveform observation. You can use the channel 1 or channel 2. Okay. So, and also the ripple factor for this software rectifier is 1.21. We know that is a theoretical value. Then click on this oscilloscope tutorial. It is available and it is similar to the normal lab CRO only. Ma. And see this simulation environment. So here we have the two options. One is off rectifier with connection, everything is design and off rectifier. So draw the circuits. You can choose this first option. Okay. See here. So here you can observe the instructions. So first you need to set the resistance values, then click on the on button on the start experiment, then double click on the sine wave generator input. This is the sine wave generator input. Okay. And on button in the sense here you can observe the on button. So this is the on button. So click on this one on button in the sense, then the CRO and also the all other things are activated. Okay. Then followed by what are the other options? No? We need to vary the amplitude and frequency using the controllers that are available. And for if you want to check out the output of the rectifiers, then you can click on the oscilloscope. This is the oscilloscope. For input, in the sense, we need to click on this one means then you can observe the oscilloscope. The waveform is observed on the oscilloscope. And if I click on this oscilloscope in the sense again, it will show the output also. Okay. So these are the controllers, so you can change for the amplitude as well as the frequency. So if I change this one in the sense, just a minute, you can observe the variations in the oscilloscope signal. Okay. Here we are changing the frequency, and this one is for the varying the amplitude of the output. If I click on this dual in the sense, you can observe both the input and output waveforms. Right. So this for a channel 2 is for only output and channel 1 is for the only input, and a dual in the sense you can observe both the input and as the. So this is the half wave rectifier. No? You need to take the printout of this one. So similar way, you can complete any of the experiments for the given instructions. Okay, right. So everyone should complete all this, any of the four experiments. Then take all the screenshots of the completed results and try to do the documentation by using the MS Word, and then take the printout of it and add it to the records. Okay, thank you.